Hey everyone, it's David from Creaform, and in this video I'm going to introduce you to the latest addition to the Creaform software module. It's a software that is designed to work with automated quality control with the cube R, and it's called VXscan-R. So the latest addition from Creaform in terms of software, VXscan-R, is dedicated to work with the cube R. Its primary purpose is to have the user program robot trajectories to scan their parts. And in this video, this is what I'm going to show you. Right away in the homepage, you can notice that there are some groups. So you can have multiple groups, and inside each group you can have multiple parts as well. So I'm going to create a new one for the purpose of this example. So right away you can see, if you're familiar with other software from Creaform, that the user interface is very similar. You get a 3D viewer in the center, the toolbar on the top section of the screen. This is where all the tools are. The tree view on the left hand side. Something that is brand new though is the timeline that we see at the bottom of the screen, and I will get to that a little bit later. Now the first thing I want to do is align my CAD in the cube R environment. To do so, I'm going to use the align tool in the toolbar. You can see that I have two options. I'm going to use the manual one for this example. So you can see I have a gizmo that I can play with to position my CAD at the proper location. Now I know how my part is physically installed on the cube, so I'm going to try to replicate that as best I can. But I do not care right now as to have a perfect match with the physical part. This we'll get later on when we'll get back to the cube. We'll make sure that everything is aligned perfectly. Now, in VXscan-R, the concept of programming the robot trajectories is a bit different, where I'm going to define some features that I want to scan, and the software will take care of the robot trajectory. So there's four different feature types that the user can define. The edge feature type will allow the user to snap on the CAD edges or line in between surfaces. This method is very good for sheet metal part, for example, where you want to have the best scan possible at the end of the part or for the trim lines. Another feature type that is available is the surface, and this one is very beneficial when you are scanning a large part like this truck hood, for example. This feature type allows the user to simply click on a surface on the CAD. You see it's highlighted in yellow before you click it. Once you do click on it, it's going to become orange, and you will see those pinkish lines created. So this represents the robot path that you created on your part. So this is very efficient when you have to scan a larger part, as it will create all the scan sweep required to cover the whole surface of the part. Now, accepting and create those paths will take a few seconds, but it's well worth the wait. The third option that we have is it's not a feature per se, it's really a manual approach. So you only have to click on the CAD some points. It will create lines between those points, and these are the trajectories that you want the scanner to cover. At this point, you do not choose how the robot will go there. This is all taken care of by the software. You just click on the CAD to create lines that you want the scanner to scan. Alright, now the fourth feature type that one can choose is the only one that is completely manual. Now, the previous three were somewhat automatic, right? We're just clicking on the CAD and all the robot trajectories is generated automatically by the software. But for those of you who have a knowledge in robotics and you want to have full control over the robot movement, you can choose the fourth feature type that we call jog. Now, this feature will allow you to move the robot axis by axis and choose exactly the movement that you want to have the robot do. You also have the robot joint here at the left of the screen, so I can rotate the table, for example. Let's switch the view. I can bring the robot a bit closer to the part. I can use the arrow in the viewer to move the robot. One thing that is kind of neat is, I'll zoom in for that. As soon as I get close to the part, you see in real time the laser on the part from the scanner, the laser from the scanner on the part, and this is how you're going to know the proper distance that you want to put the point. So you can go ahead, position the scanner there. You click on the register a point, and then from there you just move the robot to where you want to go next, and this will create a trajectory. You can hit spacebar to add another point, and then the robot will move from the first point to the second point. And using this method, you have full control over the robot movement. Now, those of you with the keen eye probably have noticed that the timeline at the bottom of the screen has filled out while I was doing some features. Now, the timeline indicates every single scan sweep there is in the program so far. Now, when I'm creating features that you see here on the left, it creates scan sweep, that is the robot movement. And as long as you create features and sweep, it will populate the timeline. Now it's red because there is some problem. If you take that slider and start moving, you will see the robot movement. And this is where I introduce you to the magic button of VXscan-R. It's here in the toolbar. It's called Reorder and Finalize. Now, what we have done so far is create features and scan sweep. But in order to have the program ready to send to the robot, we need to finalize it. And the finalize, what it's going to do is basically ensure that there is no collision of the robot with the environment. It will ensure that the metro scan is visible from the C-track. It will ensure that there is enough target from my dynamic referencing that are seen by the C-track. And also, since I'm doing a reorder at the same time, it will ensure the shortest total duration possible. So it will make sure that all the scan sweep are at the correct position in the timeline in order to get the shortest cycle time as possible. Now, this operation may take a few minutes, but again, this is well worth the time as everything that is happening now is required in order to have a perfect robot pad program. So as you can see, the finalize is done. Right away, big difference in the timeline. Now the color is all green and light blue. So this is good. This is what we want. So this brings me to the next thing I want to show you, and it's something that is really cool in my opinion. Before I go on the robot itself to test my scan, I can do it in the software using scan simulation. And to do that, I will just change the display of my CAD so we can see a little bit better. I will launch the simulation here in the toolbar. And what this does is basically running the robot trajectories, and it's also acquiring the scan. So with that, I will be able to visualize my scan again before I go on the shop floor and test my trajectories on the real thing. I will be able to see if I need to make some adjustment and add some sweeps or move some points. So this will ensure that when I get on the shop floor, I will have the best result as possible. Now, as you can see, in my case, I need some sweep to be added in the fender area. So I'll need to do a bit of modification before I go and scan the real part. Now, the next step would be to go on the shop, connect to the robot, do the positioning target acquisition using the automated tool in VXscan-R. I will also make sure that the part is aligned perfectly, and then we'll be good to go. So I'll see you there. All right, so now the offline programming is done. So we're back next to the cube. Off camera, I did acquire my target, make sure that the alignment was perfect. So we're good to go. The only thing I need to do is hit the start button. The program will be sent to the robot so we can enjoy some scanning.